This video lesson is on solving an equation using absolute values. So we talked about absolute values earlier this term. We talked about the fact that you could have the absolute value of -2 is equal to 2 because the absolute value is telling you the distance from 0. So the absolute value of +2 is also 2. Now that we've started using equations and solving for a variable, well, what happens if there's an absolute value in that variable or that equation for that variable? So when you're doing problems there's two cases when there's an absolute value. There's the case that you could actually have a positive or 0 number inside the absolute value, or that symbol could be negative. So you're going to likely have two results. So let's take a look. For example, if we have any real numbers of a and b, if the absolute value of a equals b, and b has to be greater than or equal to 0, then we could say that a is equal to b, or a is equal to -b. Because here is the absolute value. It could be equivalent to b whether it was a positive or negative integer. Let's look here. I think it's a little easier when you have an example with numbers. So if we have the absolute value of d equals 10, that means that our d could equal 10, or our d could also be equivalent to -10. Either or both, depending on the situation of the problem. So let's go on and see how this looks in a problem. So in 2007, a telephone poll was conducted to determine the reading habits of people in the United States. People in the survey were allowed to select more than one type of book. The survey had a margin of error of plus or minus 3%. This means, it got cut off a little, but that it could be 3 points higher or lower. So we're going to use a number line to determine the distribution of those who selected fiction books. So if we look at our table here, it's kind of hard to read, but this says 66%. So 66% of the people said they enjoyed reading fiction books. So that means if we had a number line here with 66 in the middle, okay, so if they tell us that there's plus or minus a 3% margin of error, that means if they're measuring 66%, it could really be 3 units to the right, as high as 69%, or it could be 3 units to the left to 63%. So that would mean that the actual accurate result would be somewhere between 63 and 69%. So let's look at another example here. This is more common what you're going to see in our pre-algebra curriculum or an algebra curriculum. So, for example, if we had the absolute value of f plus 5 equals 17, how would we go about solving this? Now remember, there's two cases. There's a case where the f value is negative, or the case where the f value is positive. So for case 1, we'll say that this is going to be f plus 5 equals 17 for case 1. So in this case, we can subtract 5 from each side and get a value of f equals 12. That's a possible solution for this. The other solution would be, well, what if this is actually negative inside? So case 2 is, what if it's f plus 5 is actually equal to -17 within the absolute value, but because it's the absolute value, it becomes positive 17. So in this case now we have subtract 5 from each side, which leaves us with f equals 17. It gets more negative, so negative 17 minus 5, negative 22. That's another possible solution. And if they were to ask you to put this on a number line, you could then have your number line. I'm going to count by 2's to or negative 22, 20, negative 18, and that actually is going to take too long, so I'm just going to put dots here. Then we'd have 10, 12, 14. So in our number line, we would have a dot at negative 22 and a dot at 12, because it could be either of those two. What I really should have done is counted by 5s or 10s there. We'll try that with the next one. So what if I had, for b minus 1 equals negative 3? Well, in case 1, well, I'm getting kind of confused by this when I look at this problem, because how can the absolute value of something be a negative? Is this even possible? This would mean that the distance between b and 1 is negative 3. And since distance cannot be negative, this is an empty set. Empty set. This is not possible. Let's make sure that that makes sense. Because the absolute value of something is the distance from 0. You can't have a 0 or a negative distance. So this can't be a possibility. Let's try another example just to give you another one like this. What if it was b minus 1 equals positive 3? That would be possible. So in case 1, we'd say b minus 1 equals 3. So add 1, b equals 4. In case 2, b minus 1 equals negative 3. Add 1, b equals negative 2. Then on our number line, we could have negative 2, negative 1, 0, 4, and then we would just plot these as filled in circles. Okay? I want you to try these two problems on your own and press pause now. Okay, the third example we have is, what if they gave you this number line, or they gave you the solutions? Could you then write an absolute value equation? So the way you go about doing this is, here we have our points. We need to find the point that is the same distance from the 11 and the 19. We need to find the midpoint. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 8 units in between them. So half of that is 4. So we want to go 1, 2, 3, 4. 15 is the midpoint. So once we have the midpoint, we can say our equation is x, or any variable you want, minus 15, the midpoint, equals 4, where 4 is half of this distance between the midpoint and each point. Here. So 4 units from 15 and 4 units from 15 to 19. You could check this too. We could go and do a check. We could say x minus 15 equals 4 plus 15 plus 15, x equals 19. And then we could do x minus 15 equals negative 4 plus 15 plus 15, x equals 11 to show that that is true. So I want you to go ahead, and this will be the last try it for this lesson, go ahead and try it here where you have x is equal to 17 or 27. And we'll practice this tomorrow in class.